Hello again to all my friends. This is Dr. Acula. Ah, ah, ah. No, of course not. It's Mr. Benjamin. Hello. Mr. Benjamin. Happy face. Happy face with a bow. Because I couldn't find a happy face emoticon that had a bow on it. That was any good, really. So, happy face with a bow. Anyways, I once went to see a doctor. His name was Dr. Acula. All he ever did was drain my blood. So don't go to see Dr. Acula. If you don't get that reference, the whole concept is, or the whole point of that is, today's lesson is on reflections. And if I get rid of the period here on doctor, it turns into Dracula. Ha 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 ha. Get it? All he did was drain my blood. Don't go to see Dr. Acula. Anyways, Dracula has no reflection, just like other vampires. Vampires really don't exist. So we're going to move on. Today's learning goals. We are going to explore the properties of reflections of 2D shapes. That's right, I learned how to do straight lines now. Ha 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 ha. So we've talked about what a Cartesian grid is. I'm just going to draw a really, really small one here. I don't know why I went away from my straight lines. So there and there. That's not entirely straight, but that's okay. And we know that when we are reading this grid, we always read the x-axis first. This is x. And then we read the y-axis first. So for example, if I had point 3, 4. Okay, I'm just going to get rid of that y, that x. This is read as x first and then y. So I would find point 3 here, 1, 2, 3, which is right there, and then go up 4. 1, 2, 3, 4. Now the reason I went to the right first and then up is because both of these values are positive. If they had been negative, I would have gone to the left and down, but they are positive. And that is from previous lessons. Today we're going to look at specific 3D, or 2D, figures, and think about how we can reflect them. So if I were to put a mirror right here, this shape would look something like this. Almost looks like a pair of glasses. See? This guy, his face is kind of cut off there, though. Definitions, things we need to talk about. A line segment is drawn between 2 points. The term perpendicular. Now, we almost always have lines that intersect each other. Sometimes lines intersect each other at different angles. Okay? Perpendicular lines will always make 90 degrees. And the way we see 90 degrees is if we see a square, just like in a triangle. A right angle triangle always has 90 degrees, okay? Well, that's not, there we go. So this side here and this side here are perpendicular. So what we can say is, when two lines intersect and form a 90-degree angle. So again, I'll draw out my little example here, that line there, 90 degrees, 90 degrees, 90 degrees, 90 degrees. It doesn't always have to be in the shape of a cross, it can be in the shape of an X as well. For example, 90 degrees, 90 degrees, 90 degrees, 90 degrees. And last but not least, like I showed before, a right angle triangle will always have 90 degrees as well. Our last definition for today is a palindrome. Now some of you are going to be saying, wait a minute, that's an English term. This is an English class. Just like when I correct you when you say, oh, me and my friends, but you actually mean my friends and I, because we always refer to others as if they were more important than ourselves. So a palindrome, I went on a tangent, I'm sorry, I'm not supposed to do that. I have to stay focused. A palindrome is a word spelled the same backwards and forwards. Now at this point you're not going to be able to see down here, so I'm going to draw a line up here. For example, mom. Mom is M-O-M. Doesn't matter if you spell it this way or this way. It's always going to be M-O-M. Same with dad. DAD this way, DAD this way. Another one is Bob. B-O-B, B-O-B. What does this have to do with math? Well, I'm going to get rid of those lines. I'm going to write mom again, because mom is the best example for this. M-O-M. If I were to put a mirror right here, split this term in half, this side would be a reflection of this side, and this side would be a reflection of this side. It's a reflection, basically, and that's what our topic is today. Now, I bet some of you are thinking, okay, big whoop, 3-letter words. I'm sure there's a lot of 3-letter words that are the same. Yeah? Well, how about this one? Race car. If I were to put a mirror, well, I can't really do it on the E, but that's okay. If I put a mirror right here, look, R-A-C, R-A-C. It's the same backwards and forwards. These are reflections, and often we will be creating reflections of words on our grids. So, first example, drawing a reflection. Now, there's a couple of different ways of doing this. The way I prefer doing it is by looking at what we have. So we have a square right here, and we want to, reflect it on this line. So this image here needs to be seen over here. Now it's going to be something like this, but that's not very accurate. How can we be accurate in finding that out? What we're going to do is we're going to draw some straight lines to our axis of symmetry. Now that's probably something I should have added to our definitions list, but that's okay. So this line right here, axis of symmetry. This is also going to act as our mirror. We need to create the reflection though. Now what I'm going to do is I'm going to draw a straight line from there to there, and I'm going to count the number of units. 1, 2. So that point, we can call that point A. That point is 2 units away from our axis of symmetry, or our mirror. So it would stand to make sense that we need to go 2 units away here. 1, 2. And there is our first point, which we're going to call A prime. Remember, prime, A prime, that symbol prime, is the image after translation. Now in this case we are doing reflections, and reflection is a translation. And again, I'm sorry you probably can't see that. Let me just move this out of the way here. I'll move that over there. Done. For some reason it took the S with it, and it also moved my square, but that's okay. We're going to do that for every other point as well. So let's take this point here, draw it to the line. That looks like 3 units, right? 1, 2, 3. We're going to go 1, 2, 3. And it should be right there. It's kind of hard to see. What I'm going to do is I'm going to erase those guidelines and put it in where it should be, right there. And if we do that with every other side of this shape, oops, 1, 2, 3. And the last part is this one back here. So that is 1, 2, 3, 4. 1, 2, 3, 4. And look at that. We got ourselves a reflection. Now, again, it's very hard to see with all these lines here, but you can easily erase your lines once you've drawn them in. Now, if these had been labeled, we had this as A. This side we know is now A prime. If this was B, this is now B prime. This side was C. This is now C prime. This was D. This is now D prime. All right? And that is how we do a reflection if we are drawing it. We measure the distances, we count the units, and we draw it out. We can also do reflections by using the coordinates that we know. So if I draw a quick image over here, for example, let's do a triangle. Nah, nah, nah. So we're going to label these points. We have 1 point there, 1 point there, and 1 point there. Let's call this A. A, if we find out the coordinates, A is 1, 2, 3, 4, 5 on our X, and 1, 2, 3, 4, 5. 5 on our Y. I'm going to get rid of those guidelines again, but we remember that it is 5 and 5. Let's take a look at the second point. Why don't we call it B? B looks like it is 1, 2, 3, 4, 5, 6. And 1, 2, 3. So it's 6 to the right and 3 up. So that would be 6x, 3y. And our last point would be C. I'm going to draw C over here. C looks like it's 1, 2, 3, 4. 4 on our x, and 1, 2, 3. 3 on our y. All right? So we can look at that shape and say these are the coordinates of triangle ABC. Now, if I wanted to reflect this triangle on, say, the x-axis, remember, the y-axis. This is the x-axis, this is our y-axis. If I wanted to reflect it onto the y-axis, that means this image needs to go over here somewhere. Now what I can do is, I can do the method we used last and kind of see where the lines are and kind of draw new lines there and say, oh, it's 4 units across, that looks like it's 5 units across, and that looks like it's another 5 units across, or 6, excuse me, and draw our triangle. But if I didn't want to do that, if I wanted to do it a different way, well, I could just look at my coordinates, right? I could say the coordinates A, or the point A is 5, 5. If I were to switch that over on the y-axis, how would I do that? What would be different? It would be flipped, right? It would be on this side. So let's take a look. I think the y would remain the same, because it's still at 5. It's still at positive 5. But the x would have to change, right? The x would actually change to negative 5. So A prime is negative 5 and 5. And that would be negative 5 and 5, right there. A prime. We can do the exact same for B and C. B prime, if it's at 6 and 3, positive 6 and positive 3, it would actually be negative 6 and 3. Now remember, we see that because when we're counting positive on the x-axis, we go to the right, and negative, we go to the left. Okay, and this is 5, this is negative 5. So this is positive 5, this is negative 5. And then all the way to 10, 10, 10. So B is now negative 6 and 3. So we can count across 1, 2, 3, 4, 5, 6, and 3 up. 1, 2, 3. So that's where our point will be. And we do the exact same with C prime. C prime, C is 4 and 3. So C prime should be negative 4 and 3. 1, 2, 3, 4. 1, 2, 3. And there's our shape, and that's our reflection. B prime, C prime. So your try this challenge for the day is to find as many palindromes as possible. For example, mom, Bob, race car. There are some that are many, 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 many letters long. Okay? And your second try this, I want you to plot the points A, 4, 5, B, negative 4, 5, and C, 0, 2, and reflect on the x-axis. On the x-axis. So remember, if your axes are something like this, and your shape might look something like that, if you're reflecting on the x, that shape should be over here. And it might look something like this. But you never know. So give that a try. And on this grid, I'm going to plot some points. Let's do Negative 5 and 5. Let's do positive 5 and 5. Let's do negative 10 and negative 5. Let's do positive 10 and positive 5, or negative 5. And let's do 0 and negative 10. And if we connect these bottom 3 dots, we got a happy face. Let me put some eyebrows there. And we'll say thank you. Oh, I drew all over my face. That's okay. Ooh, 15 minutes. I'm sorry for the longer video.